All right. So learning target 3 has to do with the differences between mass and weight. And this is kind of a tough one conceptually for 8th graders. So let's kind of get into this. So what I started with here is our definition of matter. That matter is anything that takes up space and has mass. So that's pretty much everything except things like fire. And other forms of energy. Okay, energy and matter are two different things, but we're not going to really get into that too much today. So if we're going to really look at that difference between mass and weight, we have to make sure that we have a strong grasp on what is mass. So that's why I have this question here, what is mass? So it becomes a matter of really knowing the definition of mass, and that the definition of mass is it's the measure of the size or amount of particles in matter. So the key word when we're thinking and talking about mass is the particles in matter themselves. So if you think of yourself, the fact that you as a person are made up of particles of matter. Okay, so that's where you really have to put your mind when you're thinking about mass. All right, so let's think about it in terms of these two diagrams. We have diagram A and diagram B. So I want you to make a statement about if we're thinking about mass in terms of the particles, and that's what these little circles are. These little circles represent particles. So make a statement about which box has the greater mass. If I'm looking at just counting the particles in it, what would you say? And hopefully, what you would say is that box A has the greater mass because if I count up the particles, box A has significantly more particles than box B. Okay? So then let's look at another situation. So this is a little bit more practice of thinking about mass, because let's go back in time here. Let's go back to our definition of mass. The measure of the size, so how big or small they are, and the amount, how many of them, particles in matter. So then let's go back to this one. It says, make a statement about which box has the greater mass. And hopefully you said it was box A again. So even though they both have the same number of particles, they both have, box A and B both have 9 particles in them. According to our definition of mass, it's about the size or amount of particles. A has larger particles, so therefore box A has bigger mass. So then this leads us to this question, are mass and weight the same thing, which is sort of the cornerstone of learning target 3, and the answer is no, they are not the same thing. And that's what we really want you to understand about mass versus weight. They are not the same thing. Okay? So let's take a closer look. This is all about the meanings of the two words. Okay? So again, that definition of mass, there it is again, the measure of the size or amount of particles in any object or any matter. Where weight, you guys, has a completely different definition. Look at the definition of weight. It's the force that gravity exerts on mass. Okay, so all of a sudden we've just introduced this new thing. We've just introduced the idea of gravity being related to weight. Now, as you know, gravity is the force that basically keeps us here on Earth, right? It keeps, if we jump, we come back down. If we drop something, it hits the floor, and that's because of the force of gravity. So if we're looking at the difference between mass and weight, here's the difference right here. And this is huge, is that mass is a measure of particles. And I've highlighted the word particles here because I really want you to understand that if we're talking about mass, we're talking about particles. Where weight is about the force that acts upon those particles. All right? So mass is about the particles, and weight is about the force of gravity pulling your particles down towards the center of the Earth. All right? So mass is about particles, and weight is about force. Let's look at this in a little bit different terms. Okay, so what I've written up here, it says weight will change if gravity changes. All right, so here's a picture of me. Here's me on Earth, right here. Okay, if I'm on Earth with our normal Earth gravity, I weigh 175 pounds. Yes, I know that's probably more than I should weigh, but nevertheless, that's the fact. I weigh 175 pounds here on Earth because normal gravity is pulling the particles that make up me down towards the center of the Earth. And if I stand on a scale, that scale is basically measuring that force pulling me down. Now, if I magically get transformed to the moon, which would be kind of cool, as you can see, I look exactly the same. The matter that makes me, the particles that make me, have not changed. I'm exactly the same number of particles and the same size of particles. But you have to remember now is that the gravity on the moon is only about 17% of the gravity on Earth. So there is significantly less gravity on the moon. So instead of weighing 175 pounds now look what I weigh. I weigh 29 pounds. I look exactly the same. I have the exact same number of size and number of particles, so my mass is exactly the same. But because there's significantly less gravity pulling me towards the center of the moon, only 17%, now my weight's 29 pounds instead of 175 pounds. Talk about the ultimate weight loss program. So just to sum up, you guys, what we're asking, are mass and weight the same thing? No. I want you to remember that mass is about particles and weight is about the force of gravity acting on those particles. So if I were to ask you the question, would you weigh the same on Earth and on the moon? The answer is no. You would weigh significantly less on the moon because there's less gravity pulling on your mass or pulling on those particles.